Okay, so in this video we are going to talk about the types of solutions that we can actually get. So with this one, first let's just give a definition. A system of equations is when there are two or more equations involved in a given situation. So we've been dealing with one equation up to this point. Now we're going to have two equations, which means two lines. So that's just, we call it a system. It's something, two lines that work together, two or more equations that work together. So the solution to a system of equations is where the two lines cross. Because if we think about that, that's the only place where those two lines will have the same exact coordinate. And in order for them to have the same solution, they have to have the same coordinate, right? So they have to be able to be in the same place. So there are three types of solutions when this happens, when we have two lines. So we have no solution. This is when we solve the problem and get an answer like 3 equals 2 or 0 equals 12. Well, this is not true, right? 3 does not equal 2. 0 does not equal 12. So what does this mean? What this means is no matter what number we try in the equations, we just can't get them to balance. We can't get them to work. Or at least we can't get them to work together, I guess is a better way to say that. So what does it look like? Well, we look at this, and so inconsistent, when we hear this word, it means that they don't cross. That's all inconsistent means. And then parallel also tells us they don't cross. So this inconsistent and parallel are two ways to let us know these lines do not actually intersect each other. And so there's no solution because they never actually come together. So there's no point at which both lines will actually be in the same place. They're always in a different place because they never come together. The second type of solution is one solution. So we'll look at what it looks like in just a minute. So this is when we solve a problem and we get an answer like x equals 2 or u equals 12. So we can also have fractions or decimals in this situation, but so far this is what we've been used to seeing. When we see a problem, it means it has one specific solution. It's one spot where these two lines will come together. So this is a consistent solution, meaning the lines do cross. So remember, inconsistent means they don't cross, consistent means they do cross. Independent means that the two lines are different. They have different slopes, they go in different directions. So that's a new word that we're being thrown out here, is independent lines. So both consistent and then the word intersect means that they do cross. And independent means, that can also be another way of looking at that they do cross. So it means they have one solution. So independent means they're different lines and they actually cross here. This would be the solution of the two lines. Now any point on the blue line is a solution of the blue line. Any point on the orange line is a solution of the orange line. But this is the only point that works for both lines. So that's why it's a solution of the system. Okay? All right, the last one we have is infinitely many solutions. This is when we solve the problem, we get an answer like 3 equals 3 or 0 equals 0. Well, that is true. 3 does equal 3. 0 does equal 0. So what this means is no matter what number we try, we can always get the two equations to balance. And what does that look like? So again, they're consistent because we are going to have them cross, but now they're dependent. So the last one was independent because the lines were going in different directions. They're completely different lines. Dependent actually means they are the same line. So it looks like it's one line, but there's actually two lines graphed there. They're just one right on top of the other. So no matter what point I choose for the orange line, it's also on the blue line. I can't even see the blue line because it's underneath, right? So any point I choose for the orange line will also be a solution to the blue line. So that's why there's infinitely many solutions. Because remember, a line has infinitely many points. It goes on and on and on forever in both directions, right and left here. So it just keeps on going. So I can choose any point I would like, and it's a solution to both. So this is an infinite sign, if you've never seen that, infinity sign. So infinitely many solutions. All right, so let's go ahead and look at that. So we can see this means they do cross, consistent and same line. And then dependent means that they are the same line or there's one right on top of the other. So you can kind of see that again. All right, so now let's go ahead and practice the problem. So 3 systems of linear equations are shown. For each system, choose the best description of its solution If the system has exactly one solution, give its solution. So I'm showing you one at a time, so we're going to do 3 of these. So that's why it's saying that there are 3 systems of linear equations. So we have system A, so we have line 1 and line 2. So we have our 2 equations here, and they went ahead and they graphed them. We don't have to worry about that part, but they're giving us the equations because we can tell right away from the equations, I can see that they have the same y-intercept. So I know they're at least going to cross on the y-intercept. They have different slopes, which means that they're different lines. So even if I didn't see the graph, I would know that they do in fact cross at -2 for the y-intercept. And they aren't, it's not going to be infinitely many because the slopes are different. So that means the lines are going in different directions. So they do have one solution, and we can see that right here on the graph. They cross at this one point here. So I know that they have one solution. So I'm going to bubble that in, and I'm going to give that coordinate. That's the only time you have to give the coordinate is if you do see, in fact, a solution. So it's 0 because I didn't go right or left, but it's -2 because I went down to -2. Or I went down 2. All right, the second system. So again, here we have our equations. Line 1 and line 2. So they have different y-intercepts. So they do not cross at the y-intercept. And if I notice, they have the exact same slope. So what this tells me is no matter what I do, I'm starting at -4 and -1 here. And if I'm moving up 3, right 2, well, I'm going to move up 3, right 2 every time. So no matter what I do, I'm going to move up 3, right 2. I'm going to dodge that other line every single time. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And I know I'm landing right here on the 3, but that's not actually a point. I have to do rise and run. So they're going up at the same rate, which means that they're never going to cross. So if they have different y-intercepts, but the same slope, that means that they're never ever going to cross. That actually is an indicator that they are parallel lines because they have the exact same slope. So these guys do not cross. We can see that right on here. They are parallel. Since they do not cross, there is no solution. So I just go down here and bubble in. The system has no solution. All right, the third one, we have line 1 and line 2. So again, I can see, and this one's not as nice. I would have to change this one to y-intercept, slope-intercept, form in order to compare them very quickly. So this one's not as easy to compare right off the bat with the equations, but I can compare them looking at this graph. So I can see L2 and L1, and this is how, I didn't say that out loud on the last ones, but this is line 1, line 2. It's just how they're denoting the 2 lines. So we can see they're right on top of each other. I only see one line, which means that there's one line right on top of the other line. So that means they do cross. Technically, they cross at every single point because they are the same line. So I know cross is probably not the best way to say that, but every single point of one line is the same as every single point in the other line. So since they're the same line, the 2 points, any point would work for line 1 or line 2, so they have infinitely many solutions. So you don't identify a single solution because there's any point on that line will work for both. All right, so that is the 3 types of solutions for linear systems of equations. I hope that helped, and I will see you in the next video.